The procedure of MRI transportation, permanent MRI, is very heavy. Here we can see the transportation tools, the puller hoist, the cables, and this is the magnet. The magnet is approx 10 tons. The engineer will firstly move the iron plate to make the floor even. And then they place the jacks in the right position of the magnet. And he move up the jacks. He adjusted the height of the magnet, preparing to move. And we also prepare some plastic boards. We are going to put them under the feet of the magnet. We will place in all feet of the magnet. We do this is to prepare to place the roller dollies in the space. Okay, when the height is enough, make sure the height is enough to place the roller dollies. Now we will release the jack. And as we can see that now the magnet is like suspending. And the worker will rise up the magnet again. We do this is to make the space under the magnet's foot is big enough to place the roller dollies. We must do this step by step, otherwise it will be dangerous. Okay, now the space is enough. They are going to place the roller dollies. Let's see the roller dollies looks like a tank. So sometimes we call it tank dollies. We are going to place 4 sets. We place another 2 roller dollies now. Okay, when the 4 roller dollies is well placed, now we remove the jack. And we use the belt to tie the magnet safely and tightly. And we connect the cable between the magnet and the ground anchor. This side is the magnet side. We tie it firmly. And this side is the ground anchor side. We tie the cable with a pull hoist, manual pull hoist, firmly. When the anchor and the magnet is well connected by the cable, now the worker can use this pull hoist to drag the magnet slowly. And this structure makes the power multiple. The pulling power is emphasized multiple by this structure. And now we make sure the iron plate is just in front of the magnet root, entering root. Make sure again the cable is firmly enough. Okay, now everything is well prepared. We drag it again, the pull hoist. Now we can see the magnet is moving. The very heavy magnet is moving forward, slowly and safely. Just on the iron plate. During the moving, we need to adjust the 4 roller dollies to make sure the moving direction is correct. We must make sure the balance of the magnet. And when we move 1 iron plate distance, we will use the iron plate, change the position, and go on moving. Yes, so that's all. We do it time by time. We do it again and again until the magnet finally enters the magnet room. Okay, that is the procedure of the magnet entering the shading room. Good day, everyone. This is our second training of the site planning for medical imaging equipment, part 2. After watching the video that we already know that how to transport the most complicated permanent MRI system. Because the permanent MRI system is very heavy. In most cases, the permanent MRI system is more than 10 tons. And if the permanent MRI system of 0.5 Tesla, 0.5 Tesla, the magnet weight may reach 20 tons. So moving and transport the permanent MRI is actually the most complicated in all kinds of medical imaging equipment. Compared with permanent MRI system, the systems like 1.5 Tesla, the system like a CT scanner and the system like a digital X-ray are very easy to transport because the 1.5 Tesla in most 1.5 Tesla, the weight is approximate less than 5 tons. For CT scanner, the weight is less than 3 tons, and for digital X-ray is mostly less than 1 ton. So compared with permanent MRI, they are much easier. So here, from the beginning, we are going to have a review what kind of tools during the transportation of permanent MRI. We will start from this. So if we want to make sure everything is okay for the permanent MRI, before the magnet entry, we must ensure that there are no obstacles and large turns on the route due to the system size and weight. We should check all the routing from the train to the hospital entry to the department entry, and we need to check if the route can bear the magnet's weight. We mentioned that it's more than 10 tons. And also we must consider this kind of pipes in the red circle in the image. Is this kind of things may block the entries? That is very important for permanent MRI systems. And if the routing is okay, then we use the crane and the transport vesicles to move the magnet to the department. The hospital need to contact a local crane company and prepare transport vesicles as needed, as in the below pictures. This kind of vesicles is necessary to transport. And here in this table, we can see the crane load capacity requirement for different kind of systems. For permanent MRI less than 0.4 Tesla, the crane load capacity should be 20 tons. For the permanent MRI, which is more than 0.4 Tesla, such as 0.5 Tesla, the crane load capacity should be 50 tons. The superconducting MRI because the magnet weight is less. So 10-ton crane or we can just simply use the forklift. In the right picture, forklift, which is more than 10 tons to transport the system. The CT scan, which is also less weight. We can use 10-ton crane or use fork lift more than 10 tons. And as well as the digital X-ray, we can just use a simple forklift more than 5 times is quite enough. And after the system has transported to the near the department, the hospital also need to use a prepared unloading platform as in the below image. Especially we need to consider the weight, the capacity for permanent MRI, and then we can release the MRI from the train to this unloading platform. And there are different types of unloading platform, like in the below pictures. They are the moving unloading platform, or even the unloading platform can be in the second floor or third floor. Because as we know that the 1.5 Tesla or CT scanner, if necessary, we can install in the second or third or even higher floors. So in this case, we use the unloading platform in the pictures and move the system into the hospital department. Also in the video we just watched, we note that we also need to prepare the road spill plates. When the entry routine is uneven, which is also mean not even, especially for permanent MRI, because the weight is very heavy. If there is a small step, the entry will be blocked. So we need to use this kind of plate to move in. Also, we need another type of magnet entry tools, which is called roller dollies. This kind of roller dollies, we place them under the feet of the magnet and we move very slowly into the department. And there is another type of the entry tools of the roller dollies is the 4-direction roller dollies. This kind of roller dollies can direct the different move in different, and we can use this to adjust the angle of the magnet. And how to drag such a heavy magnet? We use this kind of tool. The name is pull hoist. We also watched that in the video. And this kind of tools can load a very heavy magnet and move it gradually, slowly, and very safe into the room. Also, we use this, we call jack. The jacks, they are different type. Also, we have a long distance jack like this to lift up the magnet when we want to change the angles and put it in the final position. Also, if we want to use the power, we also need a support point for the magnet. So this is the tools we use, the ground anchor. The ground anchor with this kind of tables, then we can use our power to move the magnet in. So after everything is well prepared, we just, as in the video we watched, we use the crane and unload the magnet and put it on the unloading platform and just use the roller dollies and move the system gradually into the MRI room. So these photos. And after the system reach its final place, we just remove the roller dollies and we use the jacks. And then we we use the jacks also to adjust the angle to make the position is correct. Also, we make the direction of the magnet is correct. Just facing the operator. And then After everything is okay, we use the jack's help to remove the roller dollies. And after that, the magnet will be in the right place. So we just introduced about a permanent MRI magnet, which is very heavy. And regarding the 1.5 Tesla, and also regarding the CT and also the DR, it is much easier compared with permanent MRI. That is because the 1.5 Tesla we just mentioned, the weight is approx 5 tons, and the CT is approx 2 or 3 tons only, and the DR with 1 to 2 tons only. So we simply use the crane to lift it up, and then we just put into the unloading platform and move it with even use the just in these pictures we just use the fork to put it in the right position. That's it. That's all. So compare with permanent MRI, other equipment, the other medical imaging equipment system is quite easy to make a position. So after the introduction of the system transportation and the positioning, the next topic we are going to talk about how the installation site confirmation form. And as you can see in the picture, actually we have a site inspection form, and this is a sample. And using this form, we can confirm everything during your site visit, including, as we can see in this table, like the percentage of ferromagnetic plates in the building, like is there any transporting equipment which is less than 200 kilograms around the RF room, and how far away from the magnet center, and so on. And we use this form, when we use this kind of questionnaires, and you simply visit the sites and simply fill in this table, and that's all. And this kind of table is very clear and very easy for us to confirm if the site is okay or not. If the site is not enough, which point we need to adjust, which point we need to mention to the hospitals. So this kind of table we can send you when you visit any hospital site. And this is another page of the site inspection table. In this table, we pay attention to the size, like we need to measure the shading room size, length, width, height, and we must take measurement at the shortest 2 points. And also we have the equipment room, we have the operator's room, and we make everything simple. You just visit a site and fill this table, and that's all. And that can help us to make sure the site is okay or not. And there is also another part of this table, which we call electrical part. In this part, you simply ask or measure the hospital's input voltage fluctuation, the max deviation of voltage between phase and frequency, frequent fluctuation, input power, and grounding resistance. And we also have a reference value for your reference. So with this table, it's very easy for you to communicate and with hospital, and both with hospital and with us. So we hope this form or this table can help you in the future site inspection. And after the instruction of the installation site confirmation form, the last part of this training, we are going to talk about the frequently used electrician parts in medical imaging systems. There are some frequently used electrician parts, such as UPS, such as the generator or so on. In this part, we are going to discuss what are they. and what is their functions in the medical equipment systems. Firstly, in this photo, we can see, and this is a transformer. The transformer's function is from AC to AC, which changes the voltage of alternating current AC in power system. It can either step up, or we can say increase, or step down, we say decrease the voltage levels to ensure that the electricity is transmitted efficiently over long distance. Generally speaking, we can see this part in most hospitals just near the radiology department. So that is what we need to pay attention. Sometimes this can be an interference source. So we also need to consider the interference of this kind of electric parts. And there in this table, we can see that there is another frequently used electrician parts in imaging system, what we call UPS, uninterruptible power supply, which sustains the power supply during power failure. A UPS system consists of two main parts. The first part is the host, which is in the left picture, and the second part is the batteries, which is in the right pictures. The relationships of the host and the batteries, and also for different type of medical imaging systems, what kind of UPS should we choose? And let's see this table. For superconducting MRI, especially 1.5 Tesla, the UPS host should be at least 100 kVA. The UPS battery should be at least 120 Ah. If we use this configuration, the estimated work time during the power failure can sustain more than 30 minutes patient scan, or more than 2 hours system standby. For permanent MRI, the number is 20 kVA and 17 Ah, which is also available to support a 30-minute scan, more than 5 hours standby. For CT, which is more than 64 slides, the host of the UPS should be 100 kVA, and the UPS battery is approximately 120 Ah. Then if you use this configuration, the estimate work time during the power failure is more than 3 patient scans, which is quite enough for the power failure. And for the standby of the system is more than 12 hours. For the CT system, which is less than 64 slides, the UPS host can be 80 kVA and the UPS battery 100 Ah. Also support 3 patient scan and 12 hours standby. So finally, for the DR system, 20 to 65 kilowatts high voltage generator, we can configure the UPS host according to the generator's power. For example, if we configure 50 or 65 kilowatt high voltage generator, we recommend to use 80 kVA host of the UPS, and we configure 65 Ah battery, which can scan 3 minutes scan or 12 hours standby. The frequently used electrician parts in the imaging system also include a power stabilizer. The maintenance a constant output voltage to despite the variations in input power or load conditions. It can help to protect the electrician application from damage due to the voltage fluctuation, ensuring stable patient operation. The frequently used electrician parts in imaging system also include inverter, which is convert DC to AC, and convert directly current DC into alternating current AC, which is commonly work with solar panels in the left picture. The rectifier converts the alternating current AC into DC, commonly work in UPS system, in charging UPS batteries, which is like the right picture. So after the introduction of the different types of the commonly used